Welcome everyone. Let's begin our lesson for today by going over our learning goals and success criteria. First, what are we learning? We're learning how to compare and contrast mathematical techniques in order to solve complex problems, and how to evaluate your options when solving problems in order to solve problems in the simplest and most efficient way possible. How are we learning it? Through the properties of roots and critical arguments notes, and the properties of roots and critical arguments assignment. When could you use this? To look at difficult situations in your life and evaluate your options and opportunities in order to make the best decision for your life. How do you know you learned it? By getting a score of 4 on the properties of roots and critical arguments assignment. Now let's take a look at our agenda for today. We will begin by going over our learning goals and success criteria. While we do that, you'll fill out your Get It Started. Once you've completed your Get It Started, we'll go over it together and answer any questions that you may have. After that, we'll go over the properties of roots and critical arguments notes, and then I'll give you time to complete the properties of roots and critical arguments assignment on Desmos. Once you've completed the assignment, we'll go back over it together and answer any questions that you may have. At the end of class, we'll go back over our learning goals and success criteria while you fill out your Before You Go. Your only homework for tonight is to continue working on the Reasoning with Irrational Numbers study guide and any incomplete assignments that you may have. Let's take a look now at the properties of roots and critical arguments notes. Our notes begin with the learning goals and success criteria. Now, what are the types of roots? There's the square root, which looks like this, the square root of n, and it's some number times itself equals n. So, for instance, the square root of 64 is 8, because 8 times itself is 64. So that's the square root. Then there's the cube root, and it looks like this with the little 3 over the square root symbol. And this means we're taking a number and multiplying it by itself 3 times. Fourth root is 4 times. Fourth root is 4 times, and we could keep this going. We could do the 5th root, 6th root, 8th root. As far as we want to go, we can continue this on. So now how do we simplify roots? Well, we first want to see if it's a perfect square. Well, 9 is a perfect square, so we can take the square root of that. And that's really 3 times 3, right? 9 is 3 times 3. So when we pull it out, we should pull the 3 out because it's 3 squared. So the square root of 9 is just 3. Now let's look at the cube root of 8. Well, 8 is really 2 times 2 times 2. So it is a perfect cube because it's 2 3 times, right? So it's 2 to the 3rd power. So we can pull that out, and our answer then would be 2. Now what happens if it's not a perfect square or perfect cube or whatever we're looking for? For instance, 8 is not a perfect square. Well, we can see that it is 2 times 2 times 2, right? So we do have this first part in common. This is a 2 squared times 2. So we can pull that 2 out from the 2 squared, and we're left with 2 square root of 2. Now what about the cube root of 54? Well, we should notice that 54 is really 3 times 3 times 3 times 2. So we can keep this first part because that's 3 cubed. So we can just pull that 3 out, and we're left with then the cube root of 2 over here, and we pull out the 3 here, so we end up with 3 cube root of 2. Now simplifying root expressions. So we have 3 square root of 2 plus 5 square root of 2. Well, as long as we have the same root, we can treat that like it's a variable almost. And that means that we can combine those like terms. So we'll add the coefficients and keep the variable, or in this case, keep the square root. So this becomes 3 plus 5 is 8 square root of 2. Now when we multiply, so we multiply the coefficients and then multiply the roots. So in this case, we have 2 times 1 in reality, because this is 1 square root of 5. 2 times 1 is 2. And square root of 3 times square root of 5. So we end up with 2 square root of 3 times 5. And 3 times 5 is 15. So it's 2 square root of 15. Now, a couple formulas that you'll need for today are difference of squares. So difference of squares says that we start with a plus b times a minus b, and that's equal to a squared minus b squared. And this also works in reverse. So if we started with a squared minus b squared, that's equal to a plus b times a minus b. Now how do we use difference of squares when dealing with roots? Well, what we should notice is this says 3 square root of 2 plus 5 square root of 2 times 3 square root of 2 minus 5 square root of 2. Well, we should notice that we have a and a plus b and minus b. So we can rewrite this as a squared minus b squared. So we will take 3 square root of 2 and square that minus 5 square root of 2 squared. Now when we square this, we're going to square the coefficient and square the square root. So 3 squared is 9 and square root of 2 squared is just 2. So we end up with 3 squared and square root of 2 squared minus 5 squared and square root of 2 squared. Well, 3 squared is 9. Square root of 2 squared is just 2. 5 squared is 25. And square root of 2 squared is 2. So we end up with 9 times 2 minus 25 times 2. Well, 9 times 2 is 18, and 25 times 2 is 50. So we get 18 minus 50, which is negative 32. So this is a simple way to solve without having to actually FOIL this and then multiply everything out and combine and everything. So this is just a simpler way to do it in fewer steps. This one says 3 square root of 2 plus 5 square root of 2 plus 3 times 3 square root of 2 minus 3 minus 5 square root of 2. Well, what we should notice is if we were to group this part here and this part here, it still becomes a plus b times a minus b. So if we rewrite this, this is 3 square root of 2 plus, and then 5 square root of 2 plus 3. And this is 3 square root of 2 minus 3 plus 5 square root of 2. So if we reorder these, which we could, then we see that this is our a, and this whole thing here is our b. So we can rewrite this as 3 square root of 2 squared minus 5 square root of 2 plus 3 squared. So now we can go ahead and multiply this out. So we're going to say 3 squared and square root of 2 squared. And then here we have 5 square root of 2 plus 3 squared. Now with this, we're going to have to actually FOIL it. And when we do that, we get 9 times 2 minus 50 plus 30 square root of 2 plus 9. Now we're going to go ahead and combine these. So this negative sign goes to everything. So this becomes 18 minus 59 plus 30 square root of 2. So that's 18 minus 59 minus 30 square root of 2 because the negative sign's got to carry into everything. We'll combine these. 18 minus 59 is negative 41. And we'll keep this as minus 30 square root of 2. Now, difference of cubes. Difference of cubes states that a minus b times a squared plus ab plus b squared is equal to a cubed minus b cubed. And likewise, we could go the other way and say a cubed minus b cubed is equal to a minus b times a squared plus ab plus b squared. So in this case, we have 3 square root of 2 minus 5 square root of 2 times 18 plus 15 square root of 2 plus 50. And what we should notice is 3 square root of 2, if we square that, we get 18. And if we square 5 square root of 2, we get 50. So this is really a minus b times a squared plus 2ab plus b squared. So we can rewrite that as 3 square root of 2 cubed minus 5 square root of 2 cubed. Now we just cube these, so this is 3 cubed and square root of 2 cubed. And then we have 5 cubed and square root of 2 cubed. And when we do that, we get 3 cubed, which is 27, and square root of 2 cubed, which is 2 square root of 2. And then here we have 5 cubed, which is 125, and square root of 2 cubed, which is 2 square root of 2. So now we just combine these. So 27 times 2 is 54 square root of 2, and 25 times 2 is 250 square root of 2. Now we just combine these like terms. So we get 54 minus 250 is 196 square root of 2. Now, how do we make a critical argument? So in this assignment today, we're going to be looking at two different people's solutions to problems, and we're going to critique and decide who did it best. First of all, did they do it correctly, and which way would have been the most efficient way to do it. So, how to critique a critical argument? First thing we need to do is state how they did it. So in this case, Anne just multiplied everything out, FOILed it, and then simplified. Simon, on the other hand, used grouping and difference of squares and things like that to be able to get there. So that would be his solution. Now, next thing is, did they do it correctly? It doesn't matter if they had a more efficient way if the answer is not correct. So did they do it correctly? State if there was an easier way to complete the problem. Did they do it in the easiest way possible? And then if we're dealing with one or more students, which in this case we are, can we compare and contrast their work and decide who did it better?
Let's talk now about how to sign in to Desmos to complete your work. So what we're going to do is you're going to click on the link to go to the assignment, and it should take you to a page that looks kind of like this. And right here where it says sign in with Google, we're going to click there. It's going to pop up with our email accounts. You're going to click on your school email account, and it should already have you logged in because you should have already been logged in using Google Classroom. From there, I'm just going to click start the activity, and it will take me into the assignment and allow me to begin. So that's how you will log in to Desmos using Google.
Let's take a look now at the properties of roots and critical arguments assignment. Our assignment begins with the learning goals and success criteria. If we scroll down, there's a link here that takes us to the Desmos activity. We'll go ahead and click on that link, and it takes us to a page that looks like this. We'll go ahead and click start the activity. The activity begins with the learning goals and success criteria as well. We'll go ahead and click next. And we're given two different ways of completing root problems. So we have Anne's way here and Simon's way here. And we're going to compare and contrast and decide how they're different and how they're similar and which one we prefer. So we can take a look at the two solutions here. And notice most of the time Simon's end up being shorter. So we'll go ahead and click next. And we have our solutions. These are the second part of the solutions. Now, it says write a critique of both Anne's methods of tackling the problems and write a critique of Simon's. So we're going to say, how did Anne do it? So Anne solved her root problems through brute force by distributing and then simplifying. So that's Anne's work. Now Simon will say what he did. So he used difference of squares. He used difference of cubes. He used common factors and factoring. He did a lot of those kinds of things. So what different methods is Simon using that Anne is not using? And then the last question is, which one do you think are more efficient? Do you think Simon is more efficient than Anne? And if you do think so, why do you think so? So you'll go ahead and answer each of these questions. And then we'll go back to our Google form and click next. This will send you to your before you go. Go ahead and fill out your before you go and then submit your work on Google Classroom.